Hi guys, this is Mrs. Homer, and today we're going to be looking at selection graphs. So before we can talk about selection graphs, we need to talk about selection pressure. So selection pressure is something in the environment that affects an organism's fitness, so its ability to survive. So if a selection pressure is selecting for a trait, that trait makes it easier for the organism to survive, increasing its fitness, and that trait will become more common. So if a trait is selected for, it will become more common. If a trait is selected against, so if selection pressure is selecting against a trait, that trait has to lower the fitness of the organism, making it harder for it to survive and reproduce. And so we will see traits that are selected against, we will see them decline in the population and they might even disappear. So we're going to be focusing on traits that are polygenic, which just simply means that we will see a range of traits. So for birds' beaks, we saw a range from 5 millimeters all the way to 14 millimeters. We didn't just see small and big. We saw 5 millimeters, 6 millimeters, 7, 8, 9, 10. So a range of traits. And so with a polygenic trait, you'll have a couple vocab words that you need to know. First are extremes. Extremes are on either end of your graph. They tend to be less in the population. And so you have two extremes, one on either side of your graph. The intermediate or the average is in the center, and that's going to be what the majority of your population has. So the intermediate or average. So the first type of selection is considered directional selection. In directional selection, one of the extremes is favored or selected for. So, one of the extremes makes it easier for that organism to survive and reproduce. So, we should see an increase in that extreme and a decline in the other extreme and in the average. And so, the graph will shift towards that one extreme in one direction. So, this is called directional selection. So this could be a scenario where the trees slowly got darker over time, making it easier for the dark moths to survive and pass on their genes. So over time, the graph is shifting towards a darker population because the moths that are darker are able to survive and reproduce. Another example of this could be mice. So, mice that maybe live in a wintry area, if they are white, they have a higher fitness. So, we might see if that area becomes wintry, we might see a shift from all different colors of mice to just the lighter color mice. So, that's directional, it moves the graph in one direction. Stabilizing selection is the second type of selection graph. And in this case, the average is selected for. So the average is favored or the average is good. It helps the organism survive. So the extremes on either side are selected against. They don't necessarily survive. So let's look at this example. In this example, if you have the average number of eggs, your babies tend to survive more versus having one of the extremes, your babies tend to not survive as well. And so we'll see an increase in the average and a decrease in the extremes. And so our graph will become more narrow and will go up in the center where the average is. So this is considered stabilizing, where the average trait or the intermediate trait is selected for. It's the best one to have. Now, this type of selection will decrease your variation in your population, which can actually be harmful in terms of natural selection. So here's another example of stabilizing. If the average horse size is better, eventually you'll see more horses that are average and less that are the extremes. So that's stabilizing selection. All right, the last one is my favorite. It's called disruptive selection. In disruptive selection, both extremes are favored, meaning it's good to be on either side. And so we will see an increase in those extremes because they are selected for. And the intermediate or the average trait is actually bad to have. It's selected against. So we will see a decline in the intermediate. So our graph is going to change kind of dramatically. It's like we smack it down in the center and the sides pop up. That is disruptive selection. All right. So, an example of disruptive selection here with these beaks. If the average size beak is bad and the extremes are help them survive, we'll see a change in the population where we'll see more extremes and less of the average. So that's disruptive selection. So again, directional moves our population towards one extreme in one direction. Disruptive, both extremes go up, but the average is bad. So the average goes down. And stabilizing the average is good. So the average goes up while the extremes go down. So for each of the following graphs, I want you to answer an Ed puzzle what type of graph it is being displayed, and I'll go in for the answer. So answer this one now. So if you came up with stabilizing, you're correct because the average is best and it is increasing. The average is selected for. Try this one. If you selected disruptive, then you are correct because the extremes are selected for. So the extremes go up, but the average or the intermediate goes down. And last one. If you selected directional, you were correct because this moves the population in one direction. So one extreme was good. All right, so now we're going to have some scenarios. So what you're going to do is read the scenario and decide if it's directional, disruptive, or stabilizing, and then I'll go over the answers. So go ahead and answer this one now. All right. If you chose directional, you were correct. So we had an array of feathers, but if having the most, so on one end, one extreme was good. So the population moved in that direction. So directional selection. Go ahead and try this one. In this one, if you selected disruptive, you were correct because either having the one extreme, the white color, or the other extreme, the black color, was selected for. That was good. Those went up. But having the average color made you die, so it went down. So disruptive selection. Next example. Now, for this example, I have a lot of kids that get this wrong. This is actually directional because the larger cockroaches survive. So don't focus on what's being eaten. That's bad. Focus on what survives. The what survives is the extreme at one end. So our population will move in that direction towards that extreme. And so this is directional selection. All right, last situation. And in this one, if you came up with stabilizing selection, you are correct. In this one, the average is selected for. So the population becomes more stable, becomes more average, and you see that average increase. Because having wings that were too small or too big were bad. So having the average is what caused them to survive and reproduce. That's all I have on selection graphs. Have a great day.